Let's revisit the same scenario that we saw a few videos ago. We had the same data, but now we're asking the question, at a significance level of alpha equals 0.05, can we determine that there is a significant linear relationship between hours spent on homework and GPA? So remember, we can always calculate the line of best fit. Even if there's no relationship whatsoever, we can still calculate something. There's still formulas for that. But now we're wondering, is it actually a significant linear relationship? Do we really believe that there is a linear relationship between these variables? And so statistics allows us to come up with a rigorous way of doing that. So we're doing hypothesis testing here. So we always need your hypotheses for hypothesis testing. So your null hypothesis is going to be rho is equal to 0. So remember, rho, this Greek letter, this is going to represent our correlation coefficient for the population. And this equals 0. What we're saying is that there is no linear relationship. So there is no linear relationship. That's what we're saying with rho equals 0. But then the alternative hypothesis says, wait a minute, what if it's not equal to 0? What if there is some significant linear relationship? Because remember, we said the correlation coefficient, when it's closer to 1 or -1, there is a linear relationship. When it's closer to 0, there's not. Okay, so to be able to do this hypothesis testing, this is going to be a very easy choice. We're always going to be doing the same exact test. So if you turn on your calculator, you go over to stat, you go over to tests, you can start to look around and see, okay, we've done a bunch of these already, but what if we come across this linear regression t-test? So this linreg t-test, that's what we want. So we want to do a linear regression t-test. So we're going to select that. Now our data is still entered into L1 and L2. So we still entered our hours here. We entered this data into L1 and we entered this data into L2, our X and Y. Our frequency is 1, that's good. Our alternative hypothesis, we're saying that we're not equal to 0. We're always going to have that chosen. And then we're going to calculate this. Now, these other options of greater than 0 or less than 0, that would be if we wanted to specifically see if there was a positive or a negative relationship. But we're never going to do that in this class, so you don't have to worry about it. So now we calculate this. So what we have from this situation is we have everything that we normally do. So from here, we can find our test statistic is going to be t is equal to 6.33. Now, at this point, you should have an intuition behind test statistics and realize that's super big. That's a giant value. So my p-value should be very small. So my p-value is going to be equal to 0.0014, say, 5. Now, if you notice, there's degrees of freedom, that's 5. So in general, the degrees of freedom, which because this is a t-test, our degrees of freedom is going to be n-2. Now, you don't really need to know that, but just know that degrees of freedom is calculated a slightly different way here because it is a t-test. And then also, if you scroll down, you see some other things that we should be aware of. So for instance, A and B, we've seen that before. So if you look at the very top, you notice that we have y is equal to a plus bx. So if we plug in these numbers, y is equal to 1.957 plus 0.0728x, you notice this is our line, or our linear line of best fit. So this regression line that we had, we can calculate it by doing linear regression t-test. So we don't have to do what we did in the previous video and calculate it a different way. Once you do the actual hypothesis testing, you get that for free. Now also, as you scroll down through some of these, you can also see some other things. So for instance, we see S and we see R squared and we see R. So we'll get to S in a little bit, but our R squared and R values, those should be something that we're somewhat familiar with now. So we'll finish off this hypothesis testing before we get to those values. So as normal for our hypothesis testing, we have to finish off by comparing this to alpha. So since our p-value which is equal to 0.00145, is now a lot less than 0.05, which is alpha, we reject the null hypothesis. So we reject the null hypothesis. There is sufficient evidence to believe there is a linear relationship between hours of homework and GPA. Now remember, we said that this is important because when we know this, what we can also now conclude is that the regression line, the regression line gives meaningful approximations. Now, this isn't a requirement of hypothesis testing. The hypothesis testing will end right here. So this would conclude our question here. So we have all of this that you would need for hypothesis testing. Now, but it's on the other hand, I want to make a note though, because remember we said that using the regression line for approximations, that was useful when we did interpolation. It didn't give us values we trust with extrapolation. But also the regression line, if it's not a meaningful regression line, if we don't have our hypothesis testing that there is a significant linear relationship, well, we shouldn't trust our approximations then either. So we do know that if we do interpolation with this like we did on the previous video, we can trust our approximations. So now a few things that we can now note back to the calculator is that we see here that R is equal to 0.9429. Now this is very close to 1. Right, so this is very close to 1. So what this tells us is that we do have a positive relationship. Right, it's positive because R is positive. So this number here, this is greater than 0, because if it's less than 0, then it's going to be a negative relationship. So this is our correlation coefficient. Our correlation coefficient. And remember, this is just a statistic. This is based off of our sample. Now our R squared value, we see that is 0.8891, but really this is going to be, if we think about this as a percent, this is going to be 88.91%. And we said this was this percent of variation. So what this number is saying is that the percent of variation in the Y value. Now, the Y value we set up here was GPA. So the percent of variation in GPA, or I guess not the percent, 88.91% of variation in GPA is explained by variation in the X value. So the definition we had was in the X value, but our X value we said was in the hours spent doing homework. It's explained by variation in the number of hours spent doing homework. Then also what this implies is that 11.09% of variation in GPA is not explained by variation in the number of hours spent doing homework. And that makes sense, right? We wouldn't expect it to be perfect. Remember, we're asking, why do we have different Y values? Why is it that when I look at this chart, why do I have numbers here like 2.97? Why do I have 1.96? Why do I have 2.56? Why do I have 3.02 or 2.75? Notice in this last case, this might show it perfectly, right? We do have these two numbers. They both spent the same number of hours for their homework, but yet they have very different GPAs. So we don't expect 100% of the variation of the GPA to be based off of the hours. So we're looking at, why do we have different GPAs? Well, a lot of it, right? Almost 89% of the reason of why there's different GPAs is explained because they spend different number of hours doing homework. So that is R and that is R squared in this situation, based off of also with hypothesis testing.